Good day, everyone, and welcome to today's DevOps.com webinar. We're excited that you're here with us. Our topic today is PKI in DevOps, how to deploy certificate automation within CI/CD. It's a great topic. A lot of software being created these days, and we want it to be secure. Today's webinar is sponsored by Keyfactor. My name is Mitch Ashley, and I'm going to serve as your host and moderator. A few housekeeping items that we need to take care of. First of all, we are recording this webinar. So you can sit back and relax. Don't worry about taking a bunch of notes because we will email everybody following the webinar with a link to the recording and also a link to the slides. And we have a special ebook that will also include a link for it called Security at the Speed of DevOps, how security and DevOps can collaborate to mitigate risk. So we have an added special bonus there. At the end of the webinar, we'll be giving away 4 gift cards, so please hang around for those Amazon gift cards and see if you might be one of the winners. But we've got a fantastic group of speakers here. I'm excited for them to talk, so I'm going to get to that in just a moment, but your role in all this is to ask some questions. So put your questions in the question tab of the GoToWebinar software. Our speakers love questions. So let's move on to our topic, PKI and DevOps. How to deploy certificate automation within CI/CD. Very happy to introduce our 3 speakers. First is Chris Paul, who's Cybersecurity SME at Infinite Ranges. And then we have Anthony Reese, who's VP of Solutions Engineering at Keyfactor, followed by Ryan Sanders, who is Product Manager at Keyfactor also. So I'm going to hand the baton to you, Ryan. Take it away.
Cool. All right. Thanks, Mitch. And you might as well be one of you said 4 speakers, you might as well be one. We were talking to you earlier, you got some experience with PKI too. But yeah, thanks, Mitch, and thanks everyone for joining us. I was actually taking a look at the attendee list just a couple of minutes ago. Some of you are still rolling in. And there's a lot of dev and security folks on the call. So I'm really excited to talk about this topic. It's been coming up in almost every conversation with our customers, and that's these PKI and DevOps. So judging by the turnout today, it's an important topic for you guys too. So yeah, let's dive in. So my name is Ryan, and I'm joined by, as you can see, Anthony from Keyfactor and Chris from Infinite Ranges. And we're going to talk about where PKI kind of fits into application development and then kind of what InfoSec dev and security teams can do to secure and automate the use of those certificates in a CI/CD environment. But before we do that, let's start off with some introductions. So Anthony, why don't you go ahead and introduce yourself?
Thanks, Ryan. Appreciate it. Anthony Ricci. I'm a VP of Engineering here at Keyfactor. Been in application development consulting for a better part of about 28 years now, particularly in the IT security space and cryptography since 2005. So had a lot of experience. Looking forward to presenting some really good information to you in the DevOps world. And that's it. Thank you.
Cool, thanks, Anthony. And yeah, so we've also got a cybersecurity specialist on the call today, and probably one of the coolest LinkedIn profiles I've ever seen. So go and check it out if you haven't seen it. But Chris Paul from Infinite Ranges, our partners. Chris, why don't you go ahead and kick us off? We've got a special slide for you on that one too. So go ahead.
All right. Well, thanks, guys. I really appreciate it, and thanks to everyone in attendance. You know, I'm really happy to be here and sharing this time today. So. The reason why I'm the intro speaker here is mostly because of my background and my experience in what became DevSecOps. Okay, so my initial career started in the Army. I was a military intelligence systems maintainer integrator. Long title, really it just meant that I was a cable dog. You know, I was working on radar dishes in the desert. But going from there, you know, I worked in my way up into cyber network warfare, and I started working for the NSA. As Ryan said, cool profile on LinkedIn. I didn't try to be that way; it just kind of turned out that way. But everything on there is cleared, so don't ask questions about stuff I can't tell you. But the thing about that is, I got exposed to some cutting, like bleeding edge security tactics, techniques, procedures. I got to deal with a lot of cutting edge technology and getting to see the way that actual advanced persistent threats operated in the threat space. And one of the things that they utilized the most that I noticed was certificates, you know, just so signed certificates and going after other things like that. So what I want to say here is well, save that for later. Basically, got out of the military, got out of the 3-letter agency stuff, moved on to Knox SOX stuff. I was a tech lead for WeWork for a time, engineer at Qualys, and then I moved on to a tech startup here in Austin, Texas, where I actually got to wear multiple hats. So I started off as just sort of like your normal security guy, 10 people at this shop, and they needed someone to answer the phones because the devs were constantly working. So that turned out to me becoming a help desk guy. Then I stood up the Cisco ASA, I stood up perimeter security, I started maintaining our identity security. But then I started fielding phone calls from the insurance agents. So this was an insurance app to buy insurance mobile. So insurance agents were calling me with bugs. Well, the testers, you know, they didn't really know about this until somebody came and told them. So this was back in 2015. Really, DevOps wasn't a thing yet. DevSecOps certainly wasn't even a discussion yet. So here I was, just a guy, former military, secret squirrel, you would say, with an eye for security threats while I'm watching intake from the Cisco ASA. I'm fielding bugs and stuff from the field. I'm taking that to the testers. I'm talking to the devs specifically, and I'm walking around doing this. You know, Slack was brand new. Speaking as far as team collaboration goes. So DevSecOps, I was literally the embodiment of DevSecOps before it was a thing. Writing content, putting it out there, and sort of building on what we have learned. So that is kind of why I was in the field. I got to see what that has become now. You know, fast forward 4 or 5 years later, it's light years from where it was. So before the virus hit, the last part of my career right here, the cyber course developer, cyber operations instructor. Before the virus hit, I was flying all over the world teaching computer network exploitation and computer network defense techniques, as well as teaching people basic security fundamentals, just protecting themselves from simple spam emails, phishing scams, and you know, teaching things like certificate lifecycle management. And then cyber course developer, I wrote a red team threat emulation course that is being vetted to go into the National Cryptologic School. And so that's why I'm here today. And Ryan, if you could please, next slide, and we'll kick off. So basically, what is the DevOps mantra, right? Everybody here, well, I heard there were security folks out there, but mostly the developers, you know, the mantra is to move fast, move quick. You know, we want to automate everything that we can, fix problems as you see them, just with tape, so we can move on, right? But nearly 60%, right? They deploy multiple times a day, once a day, every few days. I mean, it's constant. Anywhere from 70% of operations pros report that developers can provision their own environments, so you know that everybody's spinning up their own thing constantly, especially developers. They want maximum privileges in their space so they can do what they need to with their tools. But things get out of control, right? So they want to automate everything. The speed happens with automation. A majority of ops, you know, 30% describe the development lifecycle as mostly automated. I would say it's way more than that, but I trust the numbers on this one. But security is left out, right? The security team is always coming like trailing behind. They're either investigating things that were brought, flags, and there's tickets that have come in. You know, they're having trouble gauging what's most important high on the priority list. But microservices, they have a lot to cover now. And one of those things is finding out like who actually owns the security on this one. So is it the developer's responsibility to do things in a secure way as they're developing in the life cycle, or is it the security team to have oversight on the developers? You know, but clarity is needed. So next slide from you. Thank you very much. So cybersecurity concerns, basically what are we seeing as the top 3 concerns still is, well, I'll skip to the second one, poor configuration, right? Accidental misconfiguration. I'm still finding credentials in scripts. I mean, there's still the simple stuff. And you think that it's like the way that hackers and threats, APTs, are getting into your systems, that there's some super complicated $1 million tool exploit that they've developed for 5-7 years. But really, it's just paying attention to network traffic, finding someone that has scripts on there, and they leave their credentials or they leave their certificate tag, their RCE tag. But anyway, anything in the scripts, right? So the other thing, lack of oversight and control, kind of goes back to what I was saying. Who's actually watching the watchers? The developers guys, are they in charge of security? Security team? The DevSecOps process, has that been really mapped out in your enterprise, your organization? But one of those things that is affected is the environment. So the third thing is environmental drift, right? Everybody's making configuration changes up and down the line. Help desk people, the security teams, developer teams, even people, there's always things being changed, and the environmental security drift of the environment sways with that. So how do you maintain an oversight from the top down, making sure that your entire organization is secure? That's kind of what I'm trying to say. The questions to ask yourself, right, to start mapping out how you feel about your place, where you are on this level. And I talk about levels mostly because of the CMMC coming out. So those of you involved in government work are going to have to become cybersecurity maturity model certified. And one of those things you have to start thinking about is all your critical assets. So do you know where all of your critical assets are? Are you able to inventory everything that you have quickly and effectively and efficiently? Are you confident these assets are deployed and configured to meet business objectives? Now, this can be security products as well for the security people here. All the tools that you're using to monitor your security persona, are they configured and are they reporting efficiently? Are your logs being dropped somewhere and you're not getting information from an endpoint? But yeah, that goes to the third question. Are you confident in your ability to measure drift in these configurations? So yes, you're getting alert logs from one place. Yes, you're getting alert logs from another place. But as you start to think about your security identity, are you seeing the holistic view of how secure you are? Are your security controls working effectively? So thank you. So now we're here to the first poll question, so I'll pass it back. Oh, I'm sorry. There you go. The first poll question here. One of the
That poll question is live now. Folks want to provide their votes. We have a whole bunch coming in. I'm excited to see what you guys think of these answers. Give it just a few more seconds here. We're almost to half of our audience that have responded. So if you want to jump in, quick do it. Great. Let's close that off and I'll show you the results and turn it back to you to talk about.
Cool. Yeah. I don't know if Anthony or Chris, you have anything to say, but I always hope that after these polls that I'll be surprised, but yet again, I'm not surprised at the results. The increasing complexity of IT and infrastructure, I mean, that's something we're going to talk about today, but I don't think that's a big surprise that that's one. And then of course, the skills and resources, I mean, that's one that we hear about, especially related to PKI pretty regularly. So Anthony or Chris, I'm not sure if you have any comments on that, but yeah, that's
totally agree with you. Yeah, the increasing complexity of IT and infrastructure wins every time.
Yeah, lots of cybersecurity skills. I think we're going to talk to both of those. It's great. You know, we have a lot of opportunity to kind of have some conversations on how you can kind of have, ways to be able to do that better in these models more effectively, because the technology is never going to stop, right? It's going to continue to evolve. So we need to evolve with it.
Yeah, absolutely. So yeah, I mean, a lot of those principles we just talked about, they also apply to PKI or public key infrastructure. So for anyone who's not really that familiar with PKI, In a nutshell, it really allows organizations to issue digital identities, which are in the form of keys and certificates. And those allow them to do things like authentication, encryption, and of course signing when it comes to software or even containers infrastructure. So the most common example is really the use of course, publicly issued SSL TLS certs that you've got on your web servers and your load balancers. But if we take a look, I mean, Mitch, we were talking earlier about this, about how PKI has kind of grown pretty significantly. If we look at PKI today versus 10 to 15 years ago, when a lot of these organizations first deployed it, it's night and day. At one time, you had relatively few certs, and those were used to protect, again, those things like your web servers, load balancers, things that you get, certs that you get from your public CAs, and then possibly you stood up your own internal PKI for things like network authentication. But over the past few years, I think what we've seen is just an exponential growth in the number of keys and certs in any organization. So this is really often driven by things like containerization, virtualization, cloud computing, IoT and mobile computing, and then of course, more recently, DevOps and the tool sets that come along with that. So in a lot of cases, organizations at this point, they really just tell us they've lost control. They don't know how many certificates they have. They have a rough estimate. So if you see there on the bottom right, the 88,000 certs, we did a survey earlier this year with Ponemon, and that was the best estimate, but it was still, I think it was 73% of organizations said they actually didn't know exactly how many certificates they had. So we know that it's up there, but we don't know that exact number because there's a lot of certificates that are untracked and unmanaged. And it's not just the number of certificates too, it's also the tools that sit adjacent to your PKI that are now either issuing or consuming those certificates. So I know that Anthony is going to dig into that a little bit, but now you have certificates being issued outside of your traditional PKI. And Chris, you talked about environmental drift. I mean, that's one of the biggest issues we see, even when PKI experts set up their PKI properly. Environmental drift configuration can change over time, and now that trust they had originally has kind of been degraded. So even when PKI is in the hands of experts, it does require quite a bit of work to make sure that it's maintained at a level of trust that you need for your organization. So overall, they really just don't know who certificates belong to, what they're being used for, things like when they expire. So of course, expiration, that's the number one reason we get calls, is they cause all kind of problems, and the main one is of course service outages. So that's the first problem. And then if we look at the second issue, it's a lack of automation. Many companies that we talk to, the processes in place for managing their certificates, everything from servicing requests to actually issuing and installing those certificates on endpoints, and then of course the eventual revocation or renewal of those certs, those processes are all still manual, and it's slow, it's time consuming, it doesn't scale, especially given the growth. So that leads to a number of different problems, and in particular with this conversation, we see developers and infrastructure teams getting frustrated with the time that it takes to get a cert, and they go off and start doing their own thing. There's a lot of tools available up there for them to do that. So you have all kinds of automated processes too, where certificates need to be provisioned very quickly. And then at the same time, you have lifespans being driven down by the Apple just cut down the lifespan of SSL TLS certs to 1 year from 2. So that's really doubled the workload for these teams responsible for managing them. So again, going back to that poll question, a lot of those challenges you guys mentioned, the increasing complexity of infrastructure, that's exactly what we're talking about, as Anthony mentioned, and the lack of skills. That's probably a close second, or maybe even tops when it comes to PKI, because it's really hard to find PKI expertise out there, but it's even harder to keep it. So any of those issues really can apply here, but I think Anthony, I'll pass it over to you now. We're gonna dive a little deeper and talk about how PKI actually fits into the whole realm of DevOps.
Thanks, Ryan. Appreciate it. So we'll kind of focus on PKI and DevOps, and we'll start with the CI/CD pipeline. And what we want to try to do here is, this is something we all know, right? We're talking about software development and the life cycle around it, and the challenges with that in a traditional software development life cycle. And what the DevOps is really doing is really creating an environment where you can kind of create applications at mass and in velocity. right? So the challenge is, from geographically dispersed development group, and when you have arduous manual processes, which I assume most of us have handled, like certainly I have in the late 90s, early 2000s, when we're deploying apps and we're pushing them to operations in a manual manner, and QA has to be involved to be able to kind of test the code. Regression testing needs to occur before it gets deployed. Then you put it into a folder that gets the ops that deploys into the production servers. And that process for every different change happens over and over again. And unfortunately, that really impedes progress, right? But you need it because you need to ensure consistency within the code and the development of your applications. And that just allows you to happen. What to me, what CI/CD means really is you're kind of merging the application developers, right? The CI component, the apps and software development, and the CD, the operations, right? The Navy, the guys that are going to carry the Marines out. Bring those two teams together, create an automated solution where you can actually deploy these builds quicker in an automated fashion and limit the human intervention through the pipeline, and then deploy that in a very automated zero-touch fashion. And these are what these tools do for us. So we go from code to committing into production, where it's CD and wherever it's going to be. And the challenge, as we all know, is, as you guys stated, is the complexity, right? It's supposed to make things simpler, but it makes it more challenging. For me personally, it does, because, I used to, and as we all do, everything really made sense when you named products and tools, right? These nice acronyms. But now we get marketing involved, and they call things that don't even make sense, right? I don't even know what these things are. Cucumber, I mean, I eat a cucumber, I don't use it. Right? Things like that are a challenge for logical people like us. And, but when we compartmentalize it, like we see here, when we talk about software, source control management or version control management, deploying it in, having a build process or a build server that gets it into a QA or a testing solution, which can kind of do regression testing and overall test the functions and features, and then deploy those into some kind of artifactory or image repository that can get provisioned, which is what we call our configuration management, which we all want to keep as immutable, into the environment, which may be a cloud-based solution, maybe a mix between bare metal and cloud, and then deploy with an orchestrator and really focus on these microservices and containerization solutions that we look like that are very ephemeral. All cool things that we're talking about, all things that we know, but the challenge is securing the pipeline, right? That's where does the X509 come into play? And really, there's two main facets here. I think one is heavier than the other in some cases, but we talk about the front end when we're deploying and we test our code sets, and then we got to check those in. We want to do digital validation, right? Create a digital signature using, the PKI solutions that we currently have at our leisure, and then be able to sign those binaries or whatever scripts that you're going to deploy into that environment. Get down to CD, where we're deploying them into those production environments, and then manage that key rotation of those certificates for a variety of different things that occur. So really, when we talk CI, I'm really focused on code signing certificates and code signing different things that you're going to use, any digital materials. And then once we move down to the pipeline and we're deploying those into the environments, we're focused on different types of certificates, whether they're SSL or mutual auth or MTLS certificates, and then managing those on a frequent basis, depending on what type of cryptography you're using, what are the length of those certificates are, and the challenges exponentially grow as those environments grow. So what do I mean by that? Let's just kind of take a focus here on, and I'll focus on the CD, is really this is just a typical or just very sample technology stack that someone may deploy. You have your physical architecture, which may be, could be cloud-based solution, could be your servers, you're separating those into certain VMs, you're slapping an orchestrator with clusters, where an orchestrator is managing those clusters in that environment across all those for a cloud-based solution. And the orchestrator is how you're deploying these microservices and pods and services that are communicating with each other. Then you may, depending on the complexity of those multi-clustered environment, you're probably implementing some kind of service mesh, right? Kind of focus on service-based discovery, management of those pods in those environments, And maybe there's a CDN on top of that, right? Maybe it's a global product. It needs high availability across multiple data centers, maybe multiple cloud services, right? So all great, very highly complex. Now let's throw digital certificates into the mix. And they can come from anywhere. All these different tools and apps have standalone CAs. Most of them do. You know, it might be something that you deploy, some open source CA that gets deployed in the cluster to kind of manage digital certificates. Kubernetes has standalone CA that you can deploy and use for a variety of different things. And then, of course, if you implement like Istio or another product similar, like from a service mesh perspective, you're going to have standalone CA there too. So even different levels of the stack, the challenges are exponentially more because you have different implementations of issuing certificate authorities. And then once you start talking about publicly trusted certificates, you know, whether it's Let's Encrypt or you're, you know, using like DigiCert or Entrust to kind of focus on your ingress or your endpoints where you're issuing SSL certificates. And maybe you have a secrets solution where you need to deploy that too that may have ICAs. And as you guys all stated in your poll, you need to understand all these technologies. And from a security perspective, the less you know about it, the more challenges and more risk you introduce into your CI/CD pipeline. So what we're talking about here is really focus on challenges that we all have as we, you know, mature our DevOps strategy and deploy that in a way where we can be secure. And now we're going to go into some other details of like what's working and what's not. Ryan, you can go ahead and forward.
Yeah, absolutely. So yeah, thanks, Anthony, for that. And a lot of those tools, like you said, I think they're pretty recognizable for this audience. I know in particular HashiCorp Vault has come up quite a bit, and of course Kubernetes and Istio. So now we've really covered how PKI and the use of X509 certs really fits into CI/CD, but let's talk more about kind of the challenges around that. So Gartner does have a lot of great content around this. If you do have access, definitely recommend it, but we'll give you a sneak peek here. So this quote really highlights a lot of what Anthony's been talking about. It's actually in the context, though, this one of container orchestration frameworks. So they're talking about Kubernetes, Docker Swarm, and Apache Mesos here. And of course, as Anthony mentioned, Kubernetes has its own built-in CA, and the others allow you to use certs issued from other CAs, and Kubernetes does too, actually. So they all have support for TLS for securing those communications between the different components within that framework, which is critical. But at the same time, developers can really use any CA to issue those certificates. And the problem is those CAs don't typically offer the level of policy enforcement and governance that these PKI and security teams are expected to maintain the level of security at. So this really adds a lot of more complexity to the way that we think about PKI compared to what we did I'd say even 2-3 years ago. So I think it's a story that we're all familiar with. It's a tale of two teams where developers and engineers, they want to move fast and security wants control. So when it comes to PKI, that story is no different. If I'm a developer, I'm probably not all that concerned with where a certificate is issued from or what policy it complies with. I just know that I need it and I need it fast. So if you're, what we see is like developers working, basically finding workarounds. They like want to avoid time-consuming processes, so they find other ways. And if you're a developer or engineer on the call today, that's not a shot at you, because after all, I don't think anyone can really blame you. If I use the example, like if I'm driving in my car and I see that something's going to slow me down ahead and my Waze or my Google Maps app tells me I have a faster route, I'm going to take that route. So if the process of generating a key pair, submitting a CSR to the PKI team, and then waiting for a certificate back, if that's too long, I'm going to find another way to get a certificate. So today, there are plenty of ways to do that. As Anthony mentioned, they can stand up their own CA. We see that in a lot of cases. Certain teams will stand up their CA for a particular use case, or increasingly they'll start to use those built-in CAs, like the ones in Kubernetes, Ansible, and Vault, or they'll use a mix of homegrown scripts in there to kind of help get those certs where they need to go. But that all needs to be maintained also. So a CA is more than just kind of getting it up and running, getting it working. You're really setting the anchor of trust for your organization. So there's a lot more that needs to go into that. It's all too easy, I think, to stand up a CA and start issuing certs, but the amount of work that goes into getting that right. Anthony, actually, maybe you could speak to this, but I mean, we actually, as an organization at Keyfactor, we help people stand up and run their PKI. We offer a PKI as a service. So we know the amount of work that goes into doing that properly. I think Anthony, you could probably speak to that better than I could.
Yeah, when we talk about like root signing, you know, key signing ceremonies that we have to go through, it should be an arduous, monotonous process that focuses on securing those keys and storing them securely as you deploy and sign your issuing CAs into your environments and certainly your CRLs. So it's a process that you shouldn't discount at all. You know, as Chris mentioned, he's finding credentials in scripts. So it's the same thing. You don't want those keys exposed because they're obviously going to open doors that shouldn't be opened by people that don't have privileges to do so. So yeah, the whole process, PKI as a theory and technology, PKI as a design is very good in my eyes. The implementation is a challenge for people, right? Getting it to work correctly in an automated fashion. So the implementation is kind of what we're going to focus on today. But as far as PKI, I think we all agree it's pure in nature and actually helps us for the non-repudiated identity management, as well as doing secure authentication between two different parties that could be anonymous in some cases.
Yeah, so I think we're going to dive in just a second. Chris is going to basically talk about what can go wrong or how things can go wrong if those teams aren't aligned when it comes to PKI. But I mean, a situation I came into, and Anthony, you have more than me, but this is one that I talked about recently, and we were doing the discovery process, and they had over 100 self-signed certificates in their environment, and I think many of those actually had a lifespan of 10 years, which is, of course, just by any means not best practice. So that really was a shocker to them. And if something goes wrong, the biggest thing is if something goes wrong, and I have it on the slide there, the accountability, say a cert expires or even a CA is compromised, it can really take hours to remediate that issue. Who issued that certificate? Where does it live? What applications are using it? How do we reissue that certificate to all those locations? And Chris, you're going to talk about that in a sec, but really it's hard to hold anyone accountable when that happens because everybody in the organization needs certs, but a lot of the times it falls back to the PKI or security team when something goes wrong with those certificates. So I know Anthony is also going to talk about kind of what it takes for DevOps to do the right thing, to allow them to kind of, as I mentioned with Google Maps, kind of take that route they need to and use the tools they want to, but stay within the confines of policy kind of guardrails. But first, yeah, Chris, let's talk about kind of what happens when things aren't aligned between these two teams.
Sure. Yeah. So that's basically why I'm here, is to scare you guys. But what happens when an outage strikes? You know, a certificate expires. It's going to cost your company a lot of money just right off the bat. I mean, as you can see, the top three incidents, LinkedIn, Oculus Rift, and then LinkedIn again, all three were caused by an expired certificate. And you think, you know, that's a big company, big website, lots of traffic, being down for 2 hours could have cost them upwards of like millions. The thing about disruption, right? When something like this happens, the entire organization is disrupted up and down. You know, you have the security guys are hopping to find the issue. Where is that certificate? I mean, we're going to talk about that in the next thing, but right, you start initiating your response. What is your PKI InfoSec? You know, they're looking for the issue. They're looking for the expired certificate. What is it? And then the teams have to be deployed to remediate, find where it is and replace it instantly, you know, but it's not instant. It takes time. So as you see, like 2 hours down here, Oculus Rift down, the Equifax breach, they didn't catch their attack for 76 days. But the average time that a threat lives in an environment is upwards of 6 months. So in my mind, right, it's pretty much dead on. Ericsson, they have a £100 million bill after they, you know, impacted users. Microsoft Teams, obviously being utilized all over as an alternative to things like Slack, but they were down for nearly 3 hours, causing them to lose, obviously, trust in their users. So there's some examples of outages and breaches. Ryan, if you would.
Yeah, and one thing
Please.
thing I just add to that is, I think, I mean, as much as we like to point these companies out, the issue is much bigger than this. I mean, I think if you look at Equifax, the actual follow-up reports, it wasn't just that one certificate that actually ended up causing that issue, or at least prolonging their inability to find that issue, but they actually had, I think it was somewhere over 300 certs, active certs that had expired at that time. So a lot of these things can kind of happen under the surface and you're not aware of them. And I think most companies we talk to don't end up in the headlines when this happens. It's just a significant blow to their operations, but it's not necessarily brought to this level of attention, but it's still certainly causing problems. So, I mean, yeah, there was another one too. Chris, we were talking about that yesterday, that the reporting of COVID cases basically in California, there was underreporting because a cert expired on that device that was supposed to transfer lab reports over to Quest Labs. So things like that can happen, but I think a lot of this happens behind the scenes too.
Yeah, thanks for reminding me on that one. That was crazy to hear about that when it happened. So yeah, some crypto incidents here I can speak to. Basically, the top one, DigiNodar, right? When that happened, they didn't even realize that Rogue Asset had got in and started issuing Rogue certificates as assigned CA. So they opened up over, I think the number was close to 350,000 Iranian citizens to having their web traffic just completely able to be viewed. Let's Encrypt revoked, 3 million certificates on March 4th due to a software bug. DigiCert obviously had to, I mean, that was a number in the millions as well. Web security certificates that were issued that had to be called back. SHA-1 broke. I forgot exactly when that happened, but when SHA-1 broke, I remember that everybody had to figure out how they were going to go through each thing, every piece of their enterprise, and figure out how to switch over to a different type of encryption. So code signing attacks, here's some more examples, right? How is code signing compromised? And like Ryan was saying earlier on the other attack slide, right? It's not only just about expired certificates, it's also about having configuration or deployment issues. It's about having your root CA set up correctly, or knowing what root CA you're trusting. But key theft, like I said about the credentials inside of scripts, there are keys, certs inside of scripts, and attackers find and steal private keys everywhere. And what they do? Well, they sell them. But signing breach, right? They infiltrate the code and signing process itself. It's not on here, but Flame is an example of that, where Microsoft, it was a vulnerability that seemed like it was signed from Microsoft. So they were just deploying it all over. And then internal misuse, right? Developers accidentally publishing private keys into publicly accessible locations. Anybody can find stuff in GitHub if they look hard enough. But yeah, Stuxnet 2010. I mean, that was a nasty one right there. I can't talk too much about that one. Had to play that close to the chest because that was about the time that I was in. But the Malaysian government, Adobe, Bit9, oh my gosh, there's some great ones on here. Sony, everybody knows when the Sony stuff happened, and all of these can be traced back to just simple not having trust on a signed certificate, basically.
Yeah, I think
Anything else?
to that point, again, like it's we've got these names on here, and this is by no means a shot at any of these companies. I mean, I've seen these names up there, and I've seen the slides on any vendor's slide deck. But I mean, it's back to what you actually just said, Chris. It's simple mistakes. If you look at, I think, what D-Link, what happened there is developers they just accidentally published firmware signing keys in the firmware that was on their site. Like that became a major issue. It actually ended up going to an investigation later related to other security incidents, but that was one that was called out in that report. So, and again, it's not just about protecting the keys themselves, but that process. I mean, that process is getting more complex. So if you think about Adobe, what happened there, they actually had code signing keys. They were kept in an HSM. They were doing it right, but the problem was the process was breached, the code signing process. And that's one thing that we come across quite a bit. And ASIS was a really good example of that recently with Shadowhammer too. So kind of just wanted to throw up this case. I'll go through it pretty quick, but it just, again, speaks to that complexity. I mean, we were talking to this guy a few months back, and this was his code signing environment. He had development teams stretched across different regions. They were using multiple solutions, build servers, and they were actually moving from TFS to Jenkins, I believe, and multiple languages and different products that need to be signed, over 100 products. And they all had different processes for doing that. And I like the way that he worded it. I remember as effort greedy. That was his big thing. He wasn't actually, security wasn't his number one concern. It was the fact that this was taking them too long. And that actually goes back to how we used to sign code at Keyfactor. Of course, we'll talk about solutions in just a sec. Anthony's going to jump in there, but we used to have only 2 guys in the company who could access a vault with a PIN. In that vault was a smart card that held our code signing key, and we would sign our code with that. That became very complex when we had multiple builds a day. That becomes really problematic. So there's a lot of problems that can kind of come up with this, and remembering a PIN alone is enough, let alone having those 2 people in the office. I mean, we look at our current situation now where we're all on this call remotely. All of our developers at Keyfactor, they're working remote too. So when you're in a situation like that, you need to make sure that those developers can still sign code. But again, same, that goes back to the TLS certificates, that they can do that in a secure way and a way that works for them within their workflow. So I'll pass it over to Anthony to run us through the solutions. But we'll do this poll question first. So this one is, what would you say is your primary concern regarding the use of keys and certs in a DevOps environment? So manual, time-consuming processes, a lack of visibility, unknown certificates, no control over the actual PKI, the issuance and use of those certs, lack of accountability, or insecure code signing or private keys. That's a little more specific. So I guess we can open up that poll now. Yeah, there we go. And you can feel free to submit your answers now.
If I had any Jeopardy music, I'd play it right now.
Nice. Yeah, these are always kind of exciting. I like being a presenter because we can see them change, and sometimes it does surprise you. Sometimes one that's in the lead, it's like watching a horse race or something. But yeah, again,
Chris,
I think,
what was the longest certificate you've seen in production? Like longest lifetime?
I think it was 7 years.
7 years, really? I saw one time we had a customer that had 100-year cert. 100 years.
What?
It was a while ago. I know. Self-signed 100-year cert they had running in production. It's crazy.
Wow.
Well, they don't have to re-enroll for a while.
Okay, we're getting some really good responses here. I think we're just at a point where I can close this off. So anybody has a response, please jump in. We'll look at the results.
Cool. Yeah, I think we'll. I know we want to move. We want to move quick. We got some solutions to get to, but yeah, Anthony, maybe you can comment on this, and then we'll jump right into your next slide.
Yeah, I mean, it's kind of what we talked about: manual, time-consuming process. Just the generation. If you're doing traditional management, keys should be stored where it's being used, right? And so you're going to do on-device key generation, CSR, passing in to get it signed. So time-consuming processes and highly complex environments, making it more challenge, especially extrapolate the number of certificates. So that totally makes sense. Lack of visibility, of course. Lack of accountability and ownership. I think because of the discounted terms of understanding, the importance of policy and procedure, that's probably why that's low. And, insecure code signing, I'm kind of surprised that that's so low at 6%. But, with the other ones, I can understand it. But code signing is important, and it should be paid, you should pay attention to that. Chris, I don't know if you have any insight here either.
No, I mean, definitely, I am surprised that the code signing isn't higher up, just because of the amount of vulnerabilities that can be found in the wild of just utilizing insecure, signed code or code from open source. And yeah, I'm just surprised that isn't higher.
Great. All right, let's go ahead and move forward, and I'll try to. I got about 10 more minutes before they pull me. Johnny Carson pulls me off. So talking about the API economy, forcing organizations to. I know only certain people understand that reference. So yeah, I'm dating myself. So the API economy forces organizations to monitor not only their own certificates, but also certificates issued and used by partners and services, which makes sense, right? You got all these different disparate systems communicating through interfaces, API interfaces. A lot of times you're doing mutual authentication, not just standard SSL TLS, and that's important, right? And management of those certificates and the trust factor between those certificates are very important. I go into organizations that this is the biggest challenge that they have. And then you create these microservices that are communicating cross-company, and cross-clouds for that matter. This is becoming ever so more important. So the whole, from the prior poll, complexity is beginning to become an issue. So visibility becomes a key factor here, right? No pun intended. But understanding, you're going in and trying to find those certificates, doing discovery, being able to kind of interrogate the trust stores, understanding what issuing CAs you have and being able to inventory those becomes very important. Control, policy, we got access control to those. Not only the authentication, to those certificates, but the authorization, like who is responsible to manage these certs, who can request these certificates. So control becomes very important. And if you have a disparate system, like I was mentioning on that one stack where you have these, issuing CAs all over the place, it's really hard to do centralized policy management from an information security perspective. Automation kind of talks to what you were saying before is, manual processes are a challenge. So creating a very streamlined approach, particularly in our world where everything is evolving into this DevOps-oriented pipelines where you're deploying these certificates, deploying these microservices or monolithic apps or whatever you're deploying into these environments in a high velocity, you want to make sure that doesn't get slowed down. So that means less manual process, more automation. So those things are very important. You want to go to the next one? So the solution is figuring it out using a CLM product, having an overarching group, InfoSec or some kind of policy enforcement governance around these certificates of where they're issued and how they're managed. So, as DevOps-oriented teams, engineers, and designers, as you're deploying these apps, you want to be a consumer of certificates. You don't want to be a manager of those. And as I showed you those stacks, you're taking on responsibility and risk for managing those CAs. And to be quite honest, it shouldn't be your job. You shouldn't have to worry about it. You should be a requester, right? So you go to the path of least resistance, and a lot of times, these are just deployed. We were mentioning self-signed certificates. I was a developer. I did that all the time, right? I got to get stuff running. I have a responsibility to deploy my functions, or I'm going to get fired, right? So deploy self-signed certificate. Put in my credentials in a script. That happens, right? You're going to take those loose ways to be able to kind of handle what you need to get accomplished. But if you had a solution that allowed you to continue your velocity at a high velocity without interfering or disrupting what you need to do for your business, and still adhere to the governance of your company or whatever industry you're on, wouldn't you want to take advantage of that? Right? That's what a CLM product does for you. It allows you the capability to consolidate those CAs, enforce policy, auditability, authorization, based access control to who can request what, and then gives control back to your organization. And it takes it out of your hands, so it lessens the risk. Ryan, you want to move to the next one? And so this is why I think this is important, even though, again, it was probably the least important on the poll. When we talk about certificates as they get deployed, whether it's MTLS certificates or you have, SSL certificates, in a lot of cases in the new world, it's going to be hundreds of thousands of certificates, especially as they become shorter lived. Like the public CA certificates are 1 year now, almost at 1 year, or they're issuing that. You got these ephemeral pods that are spinning up and spinning down that are up for a second or 2 seconds. So you have very short-lived certificates that are getting deployed out. So you're taking hundreds of thousands, millions in some cases. So velocity is a big deal, as well as management of those certificates. When we talk about code signing for very large organizations, we're talking about a handful of certificates. So think about that. You go from 1 million certificates to 2 or 3. Microsoft probably has like 3 or 4 certificates, or Google, right, that they use. But who needs to sign binaries and digital material is immense. You have tons of people, and you have organizations that are geographically dispersed. But having these code signing, as Chris pointed out, if it's mismanaged, if you have like a workstation and you have a manual process around that, that becomes a problem. So you need to find a solution that can encapsulate those code signing certificates similar to a CLM, and then be able to kind of authorize different signers so that they can sign their digital materials from a central point, and then secure that in an environment where you can't have any type of activity they'll compromise the key, right? That's what a code signing solution does. Code signing certificate is good. Management of a code signing certificate and encapsulating and creating a policy and operationalizing it is certainly better, particularly for large organizations, and certainly for organizations that are planning on doing a secure pipeline. Want to move to the next one?
Awesome. Yeah, thanks, Anthony. So yeah, it's time for Q&A. So just one quick thing I want to mention. So of course, submit your questions, but we didn't want to talk all about our product today. Of course, we do have products, but if you want to check us out, we did put resources in there, but there's also, of course, keyfactor.com. You can check out our solutions there. But we do have quite a few demos actually of these integrations. So we have an integration with HashiCorp Vault, integration with Jenkins, and actually an upcoming webinar that we're doing on Istio. I think Anthony, you're on that one. So we're going to do actually live demos of those where you can see our product in action. So check out our Bright Talk channel if you're on there. Those are pretty easy to find. But I think we're ready for Q&A.
Great. Some really good questions. I like this first question too, something we should all understand. Should we use a separate root of trust for dev versus production environments? What do you guys recommend?
You want to take that, Chris, or do you want me to take it?
No, I think you should take that one, Anthony.
Okay.
You got this.
Yeah. So, yeah, no problem. So normally what we see is we want to try to, depending on your trust boundaries, it's good to kind of create a rooted rooted CA or rooted keys around your trust boundaries, right? So if you're deploying 2 different distinctive areas, in this case, development and production, you don't necessarily want to do that, particularly if you have problems with access control to your issuing CAs. So, and certainly there may be different policies or CPCPSs around how you deploy, or practices around both of those. So the better solution is to segment and segregate based on those development trust area and then production trust area.
Okay, very good. Somebody asked a question about blockchain and how you might integrate that into CLM. What are opportunities for use of blockchain in this, or are there?
So, to me, and I hate to discount blockchain, I'm just not a big fan. I just don't see a lot of use cases around blockchain in general. It does use cryptography, but, when you talk about privatization or more publicly anonymous solutions like Bitcoins, makes probably more sense. But in an organization, I'm really grappling, I have been for years, at like where the uses come into it. Of course, PKI makes tons of sense for me, right? You're going to digitally sign a ledger. You can do that with a certificate, right? So the advantages of blockchain, particularly in like a closed environment or closed organization, I just don't see it. Chris, or?
I mean, I've seen blockchain used for a lot of things, but like you're saying, I'm certainly not a fan of it now. I don't see it working. Take a smarter mind than me.
Well, good. We had to get the blockchain question out of the way, I guess. Always comes up, right? So you guys talked a lot about expiring keys and using managed services, et cetera, to do that. So who's responsible for managing a CA in a DevOps environment? It's one you might be using for Kubernetes and Ansible. And how does that notification work if you're managing it yourself versus using a third party?
So regardless of, if it's a third-party management, you should centralize your policy within an organization, even if it's publicly or privately trusted. And with the CLM solution, you're able to do that. Now, I'm not implying that you can't let the stack, technology stack in the DevOps environment can leverage that. There are a rich set of APIs for a variety of different CLMs that you can tie into these different areas, whether it's Kubernetes or at the service mesh level. But it allows you the capabilities to consolidate the CAs and allow them to do policy enforcement at an information security level, or like a shared services PKI admin group. So everything is consolidated, auditability, management or visibility to those CAs, and then the DevOps folks, or the people, the developers and users of those environments, become more requesters or consumers of certificates and not managers of those, right? Once you start opening up, maybe a disparate management between groups that are not necessarily responsible for security, you're introducing risk to your environment.
Okay, anybody else?
Yeah, I'd agree. I think that's that's kind of what our talk is about today, right? Like it's segregating those responsibilities and allowing developers or engineers or cloud or infrastructure teams to do what they need to do, and allow the security or PKI team to do what they do best. So one of the best ways to do that is have a trusted PKI backend that's kind of plugged into these tools that you're using. It's really easy to set up a CA, but that's the problem, I think, is that it's all too easy. So.
Yeah, in addition to certificates expiring, something I've seen happen a lot is the person who sets up the PKI leaves in 5 years or whatever, and nobody knows about it, knows why, they didn't do a good CP or whatever. So it really helps to have that professionally done. We have time for, I think, one more question, about 3 minutes left in the hour here. What's the difference between using Vault as an intermediate CA versus integrating with your tool?
So when you look at Vault, Brian, did you want that?
Oh, go ahead.
Okay. Yeah. So Vault is a secrets management solution, right? So we look at it as something that consumes digital certificates behind the scenes. It wasn't built to be a truly based, CA or rooted CA for that matter, but it can do that, right? So depending on what your use cases are with Vault or secrets management, there are a few ways you can handle it. First and foremost, you should be getting visibility into it. So if you're issuing from like a Vault CA, maybe you signed it with your root CA, and that's great. That's better than just being issuing CA in there. You got to get visibility to it. But the TCO still falls on the DevOps group because they usually have control of those environments. But allowing, in a lot of the main CLMs, including us, we've built integrations into Vault where you can actually facilitate the issuance of those CAs through to our product. The first question you're probably going to ask is, well, then why wouldn't I go directly to your product? Well, we're not saying you can't do that, but it's better from a DevOps environment, as I mentioned. The whole mantra is we want to keep the velocity high. They're comfortable interfacing with HashiCorp Vault. They know the interface. So we plug in behind the scenes and do the policy enforcement so that they can do what they do best. It won't, first of all, no disruption to current processes that they have in place, but they're enforcing and mitigating the risk because you're allowing the InfoSec group or whatever PKI group to manage those certificates because it's talking to Vault. I hope that answers the question.
Yeah, I think that's a pretty thorough job there. Appreciate that, Anthony. Well, we're out of time here. I wish I had more time to answer a few more of these questions. We'll get back to folks offline. So just to wrap up things here, we want to announce our 4 gift card winners. It's Danielle G, Donna H, Kim K, and Mario H. Yay! So the good folks at Media Ops will reach out to you about getting those cards to you. It's great to get 3 experts in a room like these 3 gentlemen. Anthony Reese, Ryan Sanders, and Chris Paul. Great to listen to you guys talk. Chris, I'm glad I didn't know your bio before I agreed to do this webinar. I would have never come on. You're a scary dude. So
Oh, thanks, Jeffrey.
it's been a lot of fun, both participating and listening, and I hope our audience has had the same. So thank you for spending your time with us. You spent an hour of your time on this webinar with us, and we know your time is extremely valuable, and you know, we're honored that you would spend it with us. It's been my pleasure hosting you, and I hope that everybody's safe, well, and just be careful out there.
Thanks, everybody.
Yeah, thanks everyone.